Hey guys! Okay, so I'm going to do a quick video on today's lesson on ionic compound naming. Basically, we're going to run through 3 quick examples from this page out of our booklets. So simple binary ionic compounds, and I've numbered it page 9. So we started at the periodic table front back, and I just numbered it moving forward from there. So for me it's page 9. I'm hoping that that'll work out for you guys as well, but if not, that's the page that we're working on. So, a few things to get started on. This is the first question, and we're going to go over the first 3 questions. And a quick shortcut on how to name these a little bit faster, and then hopefully that'll give you everything you need to know. So if you're away, or it just didn't quite make sense in class, or you weren't quite ready to learn that information in class today, then hopefully you can watch or rewatch this video, and it'll make a little bit more sense. So when we're naming ionic compounds, we're talking about metals and nonmetals. And the second word always has an IDE on the end. If it has a different ending and you see it later on in your booklets, it means something else, and hopefully we'll be able to cover everything in that way so that you can see what all those other things mean as well. Okay, so the first thing I asked you guys to do was to make sure that you split your compound into its ions so that you can tell what's happening to the electrons and where they're moving. So sodium's charge is +1 and bromine's charge is -1. That means that this one is looking to get rid of 1 electron on its outer shell, and this one is looking to gain 1 more electron in its outer shell to be full. So I also talked quickly a bit about Bohr diagrams versus Lewis diagrams. This is an example of a Bohr diagram of sodium, and this is a Lewis diagram of sodium as well. These are the same thing. They show the same thing. They show the 1 electron that's in the outer shell, and this shows the 1 electron that's in the outer shell. So this is implied that it's covering all of these other electrons that are underneath. So when the electrons are transferring over, I literally draw an arrow and an X to kind of have a placeholder between the electron to show the transfer of where it's going to. So we have our Na electron, and it's moving over to our bromine. And now those things are attached. So the whole goal of binary ionic compounds is trying to neutralize themselves. So if there's a charge for one, it's trying to even out the charge for the other. So that will make a little bit more sense when we start to name bigger compounds that have more atoms in them, and all these charges are different and they're trying to match up. So this is a really, really simple version. It's probably the most simple that you're going to get, where you have an easy 1-to-1 ratio. You have 1 Na to 1 Br, and it's a perfect 1 bond match. So this is our little bond here. And our answer is just going to be NaBr that we're going to write into our answer key in the box beside the sodium bromide. So if we move over here now to magnesium sulfide, magnesium sulfide is a little bit different. Now we have a charge of 2 and a charge of -2. That means that this is trying to get rid of 2 electrons, and this is trying to acquire 2 more electrons. So it's the same principle, except that we're going to have 2 electrons moving over. So now we have what we call a double bond. This over here is a single bond, because there's only 1, and here we have a double bond. Sometimes you can have triple bonds or quadruple bonds. That means that there's more electrons up here in the charges that need to be moved. So if we were to name this, it would just be MgS, because there's a simple 1-to-1 ratio. You can move all of your electrons from your magnesium over to your sulfur. That's pretty easy as well. But once we get into something that's a little bit more complicated, like calcium chloride, it's not such a perfect match in the transfer of electrons. So calcium and chlorine have different charges, or different numbers of electrons that need to be moved or can be moved. So calcium is sitting here and it needs to get rid of 2 electrons, but chlorine can only take 1 electron. It could potentially bind with another type of element, so it could bond with a hydrogen atom, because that's an example of an atom that would take more than 1 electron, or sorry, that would take 1 electron. But because the name says calcium chloride, it's implied in the name that you can only have calcium and chlorine, and that's it. So what we have to do for that, we draw our one nice bond that goes over. But instead we have to consider another chlorine into the equation and factor it in. So we can't just add any element we want, we have to use the ones that are up in the name. So in this case, this would be Ca, Cl, 2. Okay, so 1 Ca, 2 Cls. Perfect. So basically the shortcut for this for you guys is you have to know that you're crossing them. And that will tell you how many atoms of each element you're going to have in your answer. So if we were going to talk about sodium bromide, we would write our ions to start, and all we have to do is cross them. So we cross them down to the bottom where we write how many of each atom there will be at the end, and we write them in. Now in science we're lazy, and when we have one of each, we don't bother to write it in at all. So this answer would just be sodium bromide. Okay, so same thing here for magnesium sulfate. We would do our cross. And we would get Mg2S2. Now the tricky part about this is that we need to factor out any common denominators that we see. So if we were to count these as denominators, we see that there's 2 and 2, but if we look over here at our drawing for sodium, we see that we only need 1 Mg and 1 S. So if we were to have Mg2S2, it would be more like this. So this would literally be Mg2S2, but because these aren't attached to each other, they're completely separate entities. All we really need is 1 Mg and 1 S to make magnesium sulfate. So how we do that in our cross is anytime that we see a common number down here that can be divided out, we divide them. So I'm just going to divide them by 2, and then you would get Mg1S1, but that would be MgS, and that's all we need to write. So you could literally go from this cross them over and see, oh, 2 and 2, I can just write MgS. So the last one is our calcium chloride. And this is a charge of +2 and -1. We cross those down, you would end up with CaCl2. So I'm hoping that that will get you started, and you can make your way all the way to 4.1, I believe, in your work. And hopefully that will give you everything that you need to know. All right.